Coplanar forces of magnitudes 8, 12, 10 and p newtons act at a point in the direction shown in the diagram. The system is in equilibrium. Find p and theta. So the condition that they've given us is that the system is in total equilibrium. What that means is that it is in equilibrium both vertically and horizontally. So the criteria for that is that the forces acting upwards must be equal to the forces acting downwards, and the forces acting leftwards must be equal to the forces acting rightwards. So let's resolve these forces. So besides this 12 Newton force, all other forces are acting in a diagonal manner, so we will have to resolve both of their components. For instance, this 8 Newton force, it has a upward component as well as a rightward component. The rightward component will be 8 cos 30 since it is with the angle, reference angle, and the component acting upwards will be 8 sin 30. Similarly, this 10 Newton force will have a leftward component and a downward component. The downward component will be 10 sine 45, and the one acting leftwards will be 10 cos 45. We have this p Newton force, so I will do it with a different color so we can differentiate it from the 10 Newton force components. So it will have a upward component as well as a leftward component. The upward component will be p sine theta, and the leftwards will be p cos theta. So now let's write these forces in terms of these two conditions. So as for the first one, we were talking about the vertical forces. So this p sine theta and 8 sine 30 are acting in the same direction. This will be p sine theta plus 8 sine 30. This must be equal to this downward component force of 10 sine 45. Only in this case will the system be in equilibrium vertically. So first let's simplify this further. So we can take these two like terms on the other side. This means that p sine theta is equals to 3.07. Now let's look at this second criteria, the equilibrium in the horizontal direction. So we have this 12 Newton force acting completely rightwards, as well as this 8 cos 30 which is also acting rightwards, and then the forces acting leftwards is this 10 cos 45 as well as this p cos theta. So this must be equal to p cos theta plus 10 cos 45. And again we can take like terms on both sides. So this 10 cos 45 will take to the other side. Get p cos theta is equals to 11.587. Now we need to find the value of p and theta. And if you look at these two simplifications that we had, we will see that we have p as the like terms, and we can also see another trigonometric identity, which is that sine theta divided by cos theta is equal to tan theta. So let's say if I write p sine theta divided by p cos theta. So these two p cancels out, and that leaves tan theta, which is equals to, and now we have the values of sine theta and cos theta, which will be 3.07 divided by 11.587. And when we take the tan inverse of this fraction, we will find that theta is equals to 14.5 degrees. Now we can substitute this value of theta in any of these two equations. I will take the one of p sine theta. So let's say p sine 14.5 must be equals to 3.07. So p is equals to 3.07 divided by sine 14.5, which is equals to 12.2 newtons. So we have both the values of theta as well as